Hello, welcome back to 13.1 right angle trigonometry. Again, I'm on page 933, and this time we're just going to do problem number 8, which involves trigonometry and using trigonometry to take an indirect measurement. So the problem says an escalator in a mall has to lift customers to a height of 22 feet. So from one floor to the next floor, there's a 22-foot difference. It probably sounds about right. Okay. If the angle between the escalator stairs and the ground is going to be 30 degrees, what will be the length of the escalator? Okay. So what we need to do is we need to draw a picture. And there's a little confusion over here about what part they mean length, right? So I'm going to draw a picture. Obviously it's going to be, well, maybe not obvious, I don't know. It's going to be a right triangle. And it says the angle between the escalator stairs and the ground floor is going to be 30 degrees. So this is 30 degrees. Now, I wish they'd picked a different thing, because this now makes me think, am I supposed to use the exact measurement? Because from the previous example, you know that we know the exact ratios for sine, cosine, tangent of 30 degrees. So we're going, for all of the other problems though, for the example that we did and the homework problems, these are going to be problems that you're going to use your calculator for, okay? And by the way, they're both the same. It doesn't matter. So I think that what we're going to do is we're going to find the length and we're going to estimate it. This problem should actually say, and this is where I'm being critical of how the problem's written, this problem should actually say estimate the length of the escalator, okay? Anyway, the height from one floor to the next floor is going to be 22 feet, and to find the length of the escalator, that's actually the length of the distance that the people are going to travel. So that's going to be the hypotenuse. So this will be L, which is the length of the hypotenuse. This right here is the opposite side. And of course, height is always taken at a right angle. So here's my sketch of my triangle. This is opposite this hypotenuse. I'm going to use sine. So sine of 30 degrees is going to be 22, which is the opposite side, over the hypotenuse, which is L, the length that I'm looking for. All right, and I know we got to get away from using L's, because that's a printed L. It looks like a number 1. That's why we use a cursive L. I know. Mine looks like an E or something. Nobody writes in cursive anymore. Okay. I'm going to multiply both sides by L, and I'm going to divide by sine 30. Now, if you remember from the previous video where we talked about sine, cosine, tangent of the special triangles, we know sine 30 equals 1/2. So this is 22 divided by 1/2, multiplied by the reciprocal. I'm going to get I'm going to get 44. Okay, I've already done that in my head. That's the advantage of special triangle, or special angles with special triangles. Assuming that this is an angle that's really going to be kind of off the special ones, I'm going to show you how to do this just with your calculator, so that you can do it with any angle that we have here. So again, I'm going to check, make sure that I am in degree mode, and I'm just going to do 22 divided by sine 30 degrees. And like I said, dividing by 1/2 is multiplying by 2. This tells me that the length is going to be 44, and my units are feet, so 44 feet. So if you're going to jump on the escalator here and go up to the next floor, you're going to travel a straight line distance of 44 feet. That's what it's asking.